Feel it, baby. I get two.
The ways that materials transfer heat in solids is through conduction, the transfer of kinetic energy within vibrating molecules. If we could see the microscopic internals of this aerogel, it would be apparent why that heat isn't conducted. Even though it is composed of silicon and oxygen, just like regular glass, aerogel's solid silica is much more spaced out. Because of that, the rest of it is mostly space, and while that space is filled by regular gas, the gas can't easily circulate within the aerogel pores and spread heat.
Aerogel has been called solid smoke.
It's solid!
Why, you might guess, because it has some of the properties of smoke, but it's a solid.
Solid as a rock!
In fact, it's the lowest density solid on the planet and holds the Guinness Book of World Record for the lowest density solid. It's 96% air. And yet it's a solid. You can tap on it.
I wanna tap that.
You can set it down.
Just put it down on me, put it down.
But this laser passes right through it. Unlike most solids, which have tightly packed together atoms, that's why they're a solid, because you can't move through the atoms. Aerogel is made up of clusters of atoms that are spaced out more than in most solids. The size of those spaces, called pores,
I wanna see sweat coming out your pores.
are controlled by engineers during the manufacturing process for maximum or minimum lowest density.
Silica aerogels also have unique optical properties. Look through this piece of aerogel. We can see objects clearly, even through a few centimeters of material. But unlike glass, aerogel has a slight bluish haze. The explanation for this is called Rayleigh scattering. This is a form of elastic scattering. Light collides with particles and scatters without being absorbed, and with no change in wavelength. The pore structure in aerogels functions as the scattering center. These pores, around the size of 20 nanometers, are smaller than the wavelength of visible light. Larger pores scatter light at different wavelengths as well. This variation produces aerogels' bluish haze. And it is the same scattering that explains a blue sky and a red sunset. Now we're going to talk about thermal properties. One of the ways materials transfer heat in solids is conduction, the transfer of kinetic energy from vibrating molecules. If we could see the microscopic internals of aerogel, it would be apparent why heat isn't conducted. Even though it is composed of silicon and oxygen, just like regular glass, aerogel's solid silica is much more spaced out, which minimizes conductive transfer. Since aerogel is very porous, the rest of it is mostly space. That space is filled by regular gas, but because the gas can't easily circulate within the aerogel pores, it can't spread heat. Check out this wax that melts under heat.
The heat is on. Oh, it's on the street. The heat is...
Now check out this piece of wax on top of the aerogel. When we light the flame under it, the wax isn't going to melt because the aerogel doesn't conduct heat.
The heat is on. The heat is on.
After holding the flame to the aerogel for several seconds, it's not hot at all, and I can touch it with my bare hands.
The first silica aerogels were manufactured by NASA in 1996 for use in the Conquest rocket in space. Aerogel was also used by NASA to keep the Sojourner rover warm on the surface of Mars, where nighttime temperatures can plunge to -100 degrees. Today, aerogel's applications are expanding. A single 1-inch window pane of aerogel is equivalent to the insulation provided by 32 window panes of glass. Future applications include blankets and pot holders.
a material world.
In a material world. In a material world. In a material world. In a material world. In a material world. In a material world.
You are on fire.